Welcome back to another video for the series, and today as promised, I decided to solve a problem related to trigonometry. If you wonder where my promise came from, please watch my previous video where I explained the problems that I couldn't solve because I ran out of time when taking the AIMS 10 mock test. So the reasoning comes out there, so please check it out if you're quite interested. But anyways, I think the problem was quite different, but I decided to modify this a bit because, why not? So I will show two ways of solving it, and yes, I'm not sure if this answer is correct or not because I made the problem, I made the solution. So please comment something below, or please tell me if my solution is wrong because I couldn't fact check it. So first of all, this is how it goes. I will say solution 1. Solution 1 is traditional method. So cosine 252 equals cosine 108 degrees, right? Now this is simply equal to negative sine of 18 degrees. Now this is a very classic problem where we say let x equals 18 degrees. So we have so we have 5x equals 90 degrees. Using this fact, we know that sine 2x equals cosine of 3x. Now let's modify this. So we have 2 sine x cosine x cosine x equals, the formula for this is cosine cube x minus 3 cosine of x. We know that cosine of x is definitely not equal to 0 because x is 18 degrees. So rewriting them, we have x equals 4 cosine square x minus 3 cosine of minus 3. Now let's move this while changing this. So we have minus 4 times 1 minus sine squared x plus 3 equals 0. Now it's simply quadratic equation. Let x equals sine of x. We have 4 times x plus 2x minus 1 equals 0. So x is negative 1 plus or minus square root of b squared minus 4ac over 2. But notice that sine of x is greater than 0. Thus, x equals negative 1 plus root 5. Oh, wait, what am I saying? Over 4. Because we found this, that's not the right x. Therefore, this is equal to root 5, 1 minus root 5 over 4. This is our answer. Now, I want to show my personal method. I used this method when I solved the problem from the mock test. If you're interested which problem it is, please go and check it out. Question 2. The fun way. So let's continue from here. We know that cosine of 225 degrees is equal to cosine 108 degrees. And this 108, it sounds very, very familiar. Like, very familiar. And as you have guessed, yes, it is from I would say the smart way. Now, I'm not saying that I'm smart. I'm saying that the idea that it like suddenly came out felt smart. The smart way. So, let's say that we have a pentagon like this. Now, as most of you guys know, there is a golden ratio in here. So what I mean by that is, if we say this length is 1, then this length is phi, and this is phi plus 1. Now, why did I brought this up here? And we know that this length is also phi. And that is because, looking at our triangle well, this is 108 degrees. We have phi, phi, and phi plus 1 here. Now, it may sound really familiar from here, but we simply know that cosine of 108 is equal to phi squared plus phi squared minus phi plus 1 squared over 2 times phi, using our law of cosines. So we have phi squared minus 2 phi minus 1, 2 phi squared. I don't know why, but why is writing this phi so satisfying? How should we calculate this? I think there is a smart way of doing it, but I just cannot think of it right now. By definition, this is equal to root 5 over 2. So phi squared is equal to 3 plus root 5 over 2. And we let's just calculate it. Root 5 over root 5 minus 1 minus root 5 minus 1. This is equal to, multiplying everything by 2, we have 3 plus root 5 minus 2 root 5 minus 4 over, and this is equal to 4 over negative 1 minus root 5, and then 3 minus root 5. Completing, we have negative 3 and 5, which is 2, and we have 1, so 2 minus root 5 minus 2 root 5 over 4, and thus our answer is 1 minus root 5 over 2. This is the value. And you can, what? Wait, what? I think I made mistake somewhere. I'll quickly check it. Minus, this is right, over 2 times What? 2 times phi. Yeah, this is right. The 4, the 6 plus 3 plus, that's also right. Eh? Uh, minus 1. 2 times. Oh! Huh. I didn't multiply 2 in the denominator. Here, when I multiply it by 2, I forgot to do it here. That's why. So we have 8 here. We have 8 and we have 4. And as you can see, we get the same value. It's because, yeah. And if we graph it, this seems like a reasonable answer. Yeah. So this is Enoch's method. I'm not saying that I'm smart. It's just saying that the idea of you trying to think of this was quite after I thought of this solution, I was like, oh wait, what? How did I just do that? And that's why I just named it this way. I mean, because connecting this one and this was quite fun. And this is not old school but traditional method. But as always, we need to describe our kicks here. I think our kick is letting x equals 18 here, 18 degrees, so that we use this and then use formula and then find it. Our kick here is thinking of the golden ratio and the law of cosines here. I think this was an interesting problem. Yes, and thank you so much for watching the video, and I hope to see you tomorrow. Thank you and bye.